All right, welcome. This is 2.5, the chain rule. All right, we will be taking the derivative of composite functions, meaning a function composed of another function, or maybe another function composed of a function composed of multiple functions. Who knows how many functions, right? So the chain rule allows us to take the derivative of a composite function. If the composition is differentiable, then the derivative is given by capital F prime of x equal to f prime of g of x times g prime of x. So to keep chain rule really, really, really simple, the best way to state it is what I say right below this notation. To do chain rule is the derivative of the outside function. So a derivative of the outside function. Let's see, I can put it here. Right there. Times the derivative of the inside function. That's as easy as chain rule is going to get. The derivative of the outside times the derivative of the inside. Okay, and now we get into our first rule with chain rule. It's the power rule combined with chain rule. It says if n is any real number, meaning if the exponent is any real number, and if the function is differentiable, then the derivative of f of x raised to the n is going to be n times f to the x times f of x to the n minus 1 times the derivative of the inside. So this still says the above. This still says derivative of outside times the derivative of the inside. So times derivative, oops, let's go down. So once again, same thing as above. Derivative of outside, man, it is Thursday. Derivative of outside times derivative of inside. Okay. Cool. So let's try it out. First up is f of x equals the square root of x squared plus 1. So we know we always have to rewrite our radicals. So before we get started, I'm going to rewrite this as f of x equals parentheses x squared plus 1 raised to the 1/2. Okay. And now we will apply the chain rule. The first thing we're going to do is take the derivative of the outside, meaning when I do the derivative of the outside, it's the power on the outside. So this means we'll get f prime of x, the derivative, is equal to, all right, so here, the 1/2 will come down, 1/2 times the inside function stays the same. 1/2 times x squared plus 1 to the negative 1/2. This is the derivative of the outside. And now we will multiply it by the derivative of the inside. The inside function is x squared plus 1. So that derivative is just 2x. Chain rule is done. Derivative is done. Clean it up with algebra. I'll label everything we just did again. This is outside. And this is inside. Derivative of outside times derivative of inside. And now, put this together, and it will be f prime of x equal to, and what I'm going to do now is take 2x and multiply it by this 1/2. And 2x times 1/2 is just x. So we'll be left with x times x squared plus 1 to the negative 1/2. And now rewrite it using algebraic properties. And our final answer is f prime of x equal to x over the square root of x squared plus 1. And that's it. That is it. That is how you do chain rule. Rewrite it if you have to. Then take the derivative of the outside function times the derivative of the inside function. That's it. Okay. Continue. 2. Y equals the sine of x squared. Again, this is a composition function. It is sine composed of x squared. So for this one, sine is going to be our outside function. X squared is our inside function. So when we take the derivative, we're going to have y prime equal to the derivative of the outside function. The derivative of the outside function is sine. Well, our outside function is sine, and then the derivative of sine is cosine. And the inside function stays the same. So we now have the derivative of the outside times the derivative of the inside. Our inside function is x squared. So cosine x squared times the derivative of x squared, which is 2x. This means we get our final answer of y prime equal to 2x cosine x squared. That's it. That's chain rule. Again, derivative of outside times derivative of inside. Again, 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 I know. 3. Y equals sine squared of x. Now, right now, this doesn't look like a composition function. So we have to manipulate it to make it look like one. Sine squared of x means sine times sine, or we can rewrite it exponentially as y equals, I'll put a bracket here to be neat, sine of x squared. Sine squared x and sine of x squared are exactly the same thing. But the way I rewrote it makes it look like a composition function now, right? This makes it look like a composition, which means we can now apply chain rule. And now, playing with notation, I'll say dy over dx, the derivative of y with respect to x. We will now do chain rule, and we will now do the derivative of the outside, which means the outside is the outside function to the power of 2. So this means that 2 is coming down. So you'll get 2 bracket sine of x to the first. I mean, we don't need that one there, but I'm going to use it since we're using chain rule. So there, that's the derivative of the outside. And then you will multiply it by the derivative of the inside function. The inside function is sine. The derivative of sine is cosine. Okay, chain rule's done, derivative is done, calculus is done. Clean it up. dy over dx equals 2 sine x cosine x. Now this is a good answer unless you remember your trig identities. What is the identity for 2 sine x cosine x? And that is dy over dx equals 2 sine x cosine x is the same as the double angle formula for sine. So this can also be sine 2x. Will this answer work? Sure, but it's cooler if you remember your identities. Okay, let's keep going. All right, number 4, easy stuff. So this is already in the perfect form, no manipulation needed. Let's take the derivative using chain rule. So f prime of x equals, and now we do the derivative of the outside, meaning that 4 comes down. You'll get 4 times the inside stays the same. (3x plus 1 to the third). There it is. That's the derivative of the outside. And then you will multiply by the derivative of the inside. Okay, that's it. Chain rule's done. Derivative's done. Clean up. I'm going to say this 3 times this 4. And we'll get f prime of x equals 12 times 3x plus 1 cubed. That's it. Is it that simple? It's that simple. Nothing else you can do here. Keep moving. All right, 5. d over dx of 1 over x squared plus x plus 4 to the third. All right, so we are going to take the derivative of this, and we can use quotient rule if we want, but that's going to make our life difficult. Why not rewrite it using the negative exponent rule? So if I do that, I will get d over dx of x squared plus x plus 4 to the negative 3. All I did was rewrite it using the negative exponent rule. Okay, and now take the derivative using chain rule. The negative 3 is going to come down. Negative 3 times x squared plus x plus 4. The inside stays the same, raised to the negative 4, because we take 1 away from a negative number, so it goes more negative. Okay, and then that's the derivative of the inside. Now multiply it by the, I keep saying the opposite. That's the derivative of the outside. Now multiply it by the derivative of the inside. The derivative of x squared plus x plus 4 is going to be 2x plus 1. Okay. Calculus is done. Chain rule's done. Algebra time. I'm going to take 2x plus 1 and multiply by that negative 3. I'm not going to distribute the negative 3, though. I'm going to leave it as negative 3 times 2x plus 1. So you have negative 3 times 2x plus 1 times x squared plus x plus 4 to the negative 3. Now that's okay, but again, practice rewriting using all the algebra rules. Algebra rules, algebra tools, right? So my final answer can be negative 3 times 2x plus 1 over x squared plus x plus 4 to the third. And that's it. If you want to distribute that negative 3, go ahead and do it. There's no need to, though. This is as simple as it can get. Okay. 6, same thing as above. We want to take the derivative using chain rule, but we have to rewrite this first. This is 1 over the cube root of x squared plus x plus 1. So let's rewrite as f of x equals 1 over x squared plus x plus 1 to the 1/3. If it's the cube root, then this gets written as x squared plus x plus 1 to the 1/3. And then we are going to use the negative exponent rule. Flip it up and make the exponent negative. Okay, perfect. Now we are all set up to find a derivative using chain rule, which means f prime of x, let's take the derivative of the outside, that negative 1/3 comes down. The inside stays the same. Take 1 away from 1/3, that becomes 3 over 3, so you'll get negative 4/3. And that's the derivative of the outside. Now multiply it by the derivative of the inside, which is just 2x plus 1. Okay, excellent. Now, same thing, this negative 1/3 times that 2x plus 1. So negative 1/3 times 2x plus 1 times x squared plus x plus 1 to the negative 4/3. That's a cool answer. But again, practice rewriting. All right. So the x squared plus x plus 1 will move to the denominator. And the 1/3, the 3 will be in the denominator. So here's what we're left with. Negative 2x plus 1 over 3 times x squared plus x plus 1 to the 4/3. Okay, awesome. Can we keep going on this? Yes. Is it necessary? No, but for your algebraic torture, let's keep going. Which means that this part can be rewritten as the cube root of x squared plus x plus 1 to the 4th, which then can be reduced to x squared plus x plus 1 times the cube root of x squared plus x plus 1. And then just bring this 3 down. And that's what your denominator could look like. I'm saying try it out. You don't have to, but it's great. Build your algebra skills. Know how far you can go. So our answer is the very first one. But it could be the very last one with the numerator included. I left the numerator out because I was just showing you what your denominator could look like if you decided to keep going. Just know that if you need to, if you are asked to, then you know you can. All right. Seven, g of x equals x minus 2 over 2x plus 1 to the 9th. All right. Well, we are going to be using 2 rules on this one. First is the chain rule, and second is going to be the quotient rule. Yeehaw, right? All right. So let's get started. So we can say, oops, go for it. G prime of x is equal to, first is the derivative of the outside. This is the easy part. 9 times x minus 2 over 2x plus 1 to the 8th. Oh, that's the easy part. The easy part's done. That was the derivative of the outside. Now we must multiply it by the derivative of the inside. Well, this is going to have to be quotient rule. So x minus 2 over 2x plus 1. Here is f. There's g. Which means f is x minus 2. G is 2x plus 1. F prime is 1. G prime is 2. Follow your quotient rule. And f prime times 1 is 2x plus 1 minus g prime times f. 2 times x minus 2 over g squared. Okay. Quotient rule's done. Clean this up algebraically. And we'll have 2x plus 1 minus 2x plus 4 over 2x plus 1 squared. All right. And then 2x's cancel. And we are left with 5 over 2x plus 1 squared. So this is what we get from the quotient rule. But that means we're not done, because we have to go back to the original derivative and plug that in. So in the parentheses, you will have what we just found. 5 over 2x plus 1 squared. Okay, now that is the derivative of the outside times the derivative of the inside. Yay, fun, right? All right, let's clean it up some more. Let me go ahead and rewrite everything. Okay, now, can we combine these? How can I combine these terms, or do I leave it as is? And unfortunately, this time, we cannot leave it as it is. So we are going to simplify this using some exponential properties and just some other basic algebra properties. So to start with, this becomes 9 times, and I'm going to split up the first one exponentially. I can rewrite it as x minus 2 to the 8th over 2x plus 1 to the 8th. These are the same thing. Times 5 over 2x plus 1 squared. Okay, well, now let's combine the numerators. Just for fun, I'll put 9 over 1, which means it's going to be 9 times this times that. And basically, you're just going to do 9 times 5. So you'll get g prime of x is equal to 45 times x minus 2 to the 8th over, well, 2x plus 1 to the 8th times 2x plus 1 squared. These have the same base, so this means you add the exponents, which means that we get our final answer of 2x plus 1 to the 10th. Done. All right. All right. There you go. All the arrows, right? Okay. So that one's done. Now our very last one. Yeehaw. Okay. F of x equals 2x plus 1 to the 5th times x cubed minus x plus 1 to the 4th. Okay. Once again, we're going to use 2 rules on this one. This is going to be a product rule that will involve chain rule. So, since we're going to use product rule, here's F, here's G. Two x plus 1 to the 5th, and x cubed minus x plus 1 to the 4th. Now, take the derivative of f and g using chain rule. So, f prime. The chain rule derivative, so for 2x plus 1 to the 5th is going to be 5 times 2x plus 1 to the 4th. That's the derivative of the outside. Times the derivative of the inside, which is just going to be 2. Okay. Clean this one up, and we'll get 10 times 2x plus 1 to the 4th. There's f prime. G prime. Four times x cubed minus x plus 1 to the 3rd. 4 times x cubed minus x plus 1 to the 3rd times the derivative of the inside, 3x squared minus 1. Okay, clean it up, and we'll get 4 times 3x squared minus 1 times x cubed minus x plus 1 cubed. We are now ready to finish our product rule. So we're doing a product with the chain. So we just chained f and g. Now we can finish the product rule. So let's going to be f prime g. So f prime of x is going to be 10 times 2x plus 1 to the fourth times g, x cubed minus x plus 1 to the fourth. Okay? Plus g prime f. Four times 3x squared minus 1 times x cubed minus x plus 1 cubed times 2x plus 1 to the fifth. Okay, there it is. Product rule, chain rule, calculus, done. Next is clean up algebraically. All right. So let's start slow. Well, how slow, right? Well, let's build our greatest common factor. That's what we're going to do. We're going to build our greatest common factor. So here's 10 and here's 4. What is the biggest number I can pull from 10 and 4? And that number happens to be 2. All right. Then let's look at the next greatest common factor. 2x plus 1 to the fourth, 2x plus 1 to the fifth. How many 2x plus 1s can I factor out? The most I can take out is 4. So I'll have to the fourth. And then let's look at the next greatest common factor. X cubed minus x plus 1 to the fourth, x cubed minus x plus 1 to the third. How many of those can I take out? 3. Okay. All of that is my greatest common factor, right? That's my greatest common factor. So what's next is whatever is left over after we factor this huge greatest common factor out, all right? So pretty color for brackets, okay. So first up, if I factor 2 from 10, I get 5. If I factor 2x plus 1 to the fourth from 2x plus 1 to the fourth, those will cancel. And then if I factor x cubed minus x plus 1 to the third from x cubed minus x plus 1 to the fourth, how many are left over? You will have 1 left over. All right, let's do it all over again. If I take 2 from 4. If I factor 2 from 4, that leaves me with 2. If I take 4 of these from 5 of those, if I take 4 2x plus 1s from 5 2x plus 1s, I'm left with 1 2x plus 1. And then if I take 3 of these from 3 of those, so 3x cubed minus x plus 1 cubes from 3x cubed minus x plus 1's cubed, those will cancel. So all I'm left with is 2 times 2x plus 1 times close magical bracket. Okay. Ooh, still not out of it yet. The greatest common factor, everything on the left side, we're going to leave alone. Everything inside the brackets, we have to distribute and simplify. So let's keep the fancy brackets going. What did I do wrong? That should not be a 4. That should just be 1. I was like, it can't distribute that 5 in there. I took 3 from 4, so that'll be a 1. Oh man, telling you, end of the week, 5x cubed minus 5x plus 5 plus 2 times, FOIL those, 6x cubed minus 2x plus 3x squared minus 1. Close that. Close fancy bracket. Keep this fancy bracket game going. Okay, distributed that 2. And now combine like terms, and we should have our final answer. So let me bring the greatest common factor back down. No more fancy brackets needed. We're combining like terms. And x cubed, I have 5x cubed and 12x cubed. And then x squared, there's only 1. And then x's, I have negative 5x and negative 4x, so minus 9x. And then constants, right? So let me mark off what I used. It was 17x squared, 6x squared, negative 5, negative 4, negative 9x squared, and then 5 minus 2, we are left with 3. Okay? And there's the final answer. Woof! After lots of algebra. Oh, man. That is done. And that is chain rule. Again, keep it really, really simple. Derivative of outside times derivative of inside. And simplify. There you go. That's it. Chain rule. Done.